I will introduce React presented at ICLR 2023. First, we will discuss the integration of reasoning and action in AI models and the limitation of existing research. Human intelligence combines reasoning and action to make higher-level decisions. For example, when cooking, if all ingredients are ready, we naturally decide that boiling water is the next step. However, most large language models have traditionally treated reasoning and action as separate tasks. The chain-of-thought approach enables step-by-step logical reasoning. However, it relies on fixed internal knowledge and does not interact with the real world, leading to factual errors and error propagation. On the other hand, action-only models focus purely on performing actions without goal-oriented reasoning. As a result, they often engage in repetitive, meaningless searches. To advance AI capabilities, integrating reasoning and action is crucial. Future models should effectively combine both to enhance decision-making and interaction with real-world environments. Now, let's introduce React, a framework that integrates reasoning and action to enhance decision-making in AI models. Conventional AI models operate by selecting an action based on a given state. This follows a straightforward state-action process, but it lacks deeper reasoning and adaptability. React introduces a new paradigm where reasoning and action occur in an interleaved manner. Instead of merely selecting an action, the model actively reasons before and after each step, ensuring more informed decision-making. First, the model engages in reasoning to determine the best next step. Then, it performs an action to interact with the environment. Next, it observes the outcome of the action and collects new information. This process repeats iteratively, refining decisions at each step. By continuously reasoning and acting, React enables models to dynamically adapt, improving their ability to handle complex real-world scenarios. To assess React's effectiveness, they conducted experiments on 4 benchmarks. First, let's look at 2 key tasks, Hotpot QA and Fever. Hotpot QA is a QA task requiring reasoning across multiple documents. Traditional LLMs, particularly those using the chain-of-thought method, rely only on internal knowledge. This often results in misinformation or hallucinated content. Fever is a fact verification task that categorizes a claim as supports, refutes, or not enough info. For example, if given the claim Isaac Newton discovered relativity, the model should classify it as refutes. Both HAPA-QA and Fever emphasize the need for models to retrieve external evidence rather than relying solely on internal knowledge. This highlights the importance of integrating reasoning and action to ensure factual accuracy. Beyond fact-checking and QA, they also evaluated React on interactive decision-making tasks ALF Word and WebShop. ALF Word is a text-based environment designed for household object retrieval and manipulation. Instead of using a complex 3D simulation, all interactions occur through textual descriptions. WebShop is a task where an AI agent browses a virtual online store, researches for suitable products, and makes purchasing decisions. For instance, if a user says, "I need a bedside table with drawers, preferably in nickel color, under $140," The AI selects the best product and proceeds with the purchase. Both ALF Word and WebShop require the model to interact with external environments dynamically. This demonstrates React's ability to go beyond static reasoning and take meaningful actions in real-world scenarios. ALF Word operates in a fully text-based environment where the model receives an observation, tasks an action, and gets a new observation based on its choice. Let's watch this video. This is the result of comparing several methodologies for the same task at ALF Word. Let's consider the task. Put some pepper shaker on a drawer. If the model relies solely on actions without reasoning, it moves randomly in search of the shaker, attempts to pick it up in incorrect locations, and often fails to find it. This highlights why integrating reasoning with actions is crucial. Without reasoning, models lack direction, leading to inefficient and incorrect behavior. Now let's see how React handles the same task. React thinks first, where is the pepper shaker most likely placed? React searches smartly. It starts looking in the most probable location instead of moving randomly. Next, React adjusts its plan. If the shaker isn't found, it updates its reasoning and searches efficiently. Finally, React completes the task. It finds the shaker and correctly places it on the drawer. By combining reasoning and action, React ensures efficient and goal-directed behavior, leading to better decision-making in interactive environments. Next, let's look at an example from the Hotpot QA benchmark. The question is as follows. In the standard approach, the model generates a simple static answer based only on its internal knowledge without searching or reasoning. As a result, it may produce incorrect information, for example, claiming that the Apple remote was originally designed for the iPod, which is false. COT often generates incorrect answers by making false connections. Since they rely only on internal knowledge without external verification, they are prone to hallucination issues. The model retrieves information about front row, but fails to determine which device controls it. This highlights its inability to conduct proper logical reasoning. Unlike previous models, React combines thoughts, actions, and observations to derive the correct answer efficiently. They evaluated React against the existing models like Butler and Actually. The results show that React achieves up to 34% higher success rates in various tasks. By integrating reasoning with actions, React makes more informed decisions, reducing errors and improving efficiency. For Hotpot QA, they compared their effectiveness with different models. The standard model relies on nearly random reasoning. COT improves results but is limited by internal knowledge. COT-SC enhances accuracy by generating multiple answers and choosing the most frequent one. Actually struggles since pure search is not enough. React performs better than Actually, but can be inefficient in searching. Combining COTSC and React achieves the best performance by leveraging internal knowledge first and refining with external search. While React alone is slightly weaker than COTSC, combining them leads to the best overall results. Thank you for listening.